Decoding the power ramp calibration pattern. Okay, let's just jump right into this explainer. Listen, if you've ever spent entirely too much time perfectly aligning a piece of seriously expensive birch plywood, only to have the final engraving come out looking like, well, basically a piece of charcoal, you absolutely know that pain. It's the worst, right? Well, today, we are going to break down a highly effective tool generated by systems like LaserBench that's going to eliminate that guesswork entirely and save your precious materials. Seriously, it makes you wonder, how well do you actually know your laser's true power limits? Because so often, we just punch a random number into the software, hit start, and cross our fingers hoping for the best. But here's the thing, every single material, from that birch plywood to clear acrylic, reacts completely differently. If you're tired of ruining materials by just guessing your power thresholds, this continuous gradient solution is literally a game changer for how you work. We need a precise visual map to actually know your laser's true power limits. Because so often, we just punch a random number into the software, hit start, and cross our fingers hoping for the best. But here's the thing, every single material, from that birch plywood to clear acrylic, reacts completely differently. If you're tired of ruining materials by just guessing your power thresholds, this continuous gradient solution is literally a game changer for how you work. We need a precise visual map of that reaction, and this is how we get it. And that brings us to the core. Laser behaves at every possible microscopic power level right between those two extremes. Now, you might be thinking, hey, I already use a power/speed matrix, and that's great, but this illustrates exactly why the ramp is so special in comparison. You see, a standard matrix gives you a rigid grid of separate, discrete jumps. You test at 20%, then 30%, right? But the power ramp gives you a continuous visual gradient. Instead of skipping right over those really subtle changes, you get to see exactly how your material responds to the most minute, continuous shifts in power. It ensures you don't completely miss that absolute perfect sweet spot that might be hiding right between two discrete settings on a standard grid. Okay, Section 1, Under the Hood, How the Ramp Works. Let's move on and look at the actual mechanics here. So what's the machine actually doing? The execution is beautifully simple, and the best part is, the software does all the heavy lifting for you. First off, the machine executes a single pass at a fixed, constant speed. We lock that variable in so it doesn't mess with our results. Second, as it makes that pass, the software breaks the line down into exactly 40 miniature gradient rectangles, effortlessly bumping the power up just a tiny fraction of a percent at every single step. And finally, it automatically burns labeled output text right next to the ramp. It shows you the exact power range and feed rate used, so you literally never forget the parameters of that specific test. When the burn is done, it's honestly fascinating to see how the materials react across this one block. On the far left, which is your minimum power, you might see just a whisper of a mark. Or, depending on what you're cutting, like maybe clear acrylic, you might see nothing at all. But as your eye tracks to the right across those 40 steps, you watch this incredibly smooth, continuous transition into a deep, dark burn, or maybe even a complete, destructive cut where the laser finally maxes out its power limit on the far right side. Moving right along to Section 2, the trigger. When to use the power ramp. Let's talk about timing. Having a great tool is awesome, but knowing exactly when to drop it into your workflow is what's going to save you massive amounts of time. You'll want to fire this up in 3 main scenarios. First, for first-time material testing. Say you just dropped some serious cash on a sheet of exotic hardwood. You don't want to waste half the board figuring out how it burns, right? This is the quickest way to get a feel for it. Second, for finding power boundaries. You can map the exact threshold where a really nice surface engraving suddenly turns into a deep cut. And third, just for validating your machine settings. If you just cleaned your lens or updated your firmware, running a quick ramp confirms your laser's power range is doing exactly what it's supposed to do. Now, for the advanced users who want to dig a little deeper, the generator uses a few core parameters. The starting power on the left, that's power min, defaults to 50, while the right side scales all the way to power max, which is usually set to PWM max. Okay, what does that mean? It basically just tells the software to pull the absolute maximum pulse width modulation, or peak power, that your specific laser can output. The feed rate, or speed min, defaults to a constant 500, and the physical height of the ramp block size, is set to 10 millimeters. The real beauty here? You can easily tweak any of these to perfectly map the unique limits of your specific setup. All right, let's hit Section 3, the Expert Playbook, Calibration Pro Tips. Let's get into the workshop insider knowledge. Listen, if you take only one single thing away from this whole explainer, please let it be this. Always run this quick, continuous power ramp before you run a massive power/speed matrix. A full matrix, that eats up a ton of time and uses up a lot of material. By running this simple ramp first, you instantly trim away all those useless power levels that do absolutely nothing, or the ones that just turn your wood to charcoal. You then take those refined minimum and maximum numbers, plug them into your matrix generator, and boom, you completely eliminate all that wasted effort. Also, make sure your test speed perfectly matches your intended final production run. By standardizing that speed, you cleanly isolate power as the one and only variable you're testing. Once you pull that finished gradient out of the machine and spot that gorgeous, perfect hue or depth you were looking for, grab a physical pen and literally circle it right there on the wood. Since the test has 40 distinct steps, you can easily trace your pen mark down to the exact power percentage that achieved it. Keep that marked piece of scrap right on your workbench. Trust me, it is incredibly satisfying to never have to guess again.